All right, and we're back. And next we have VRotors.
My company is VRotors. Our software platform provides real-time control of drones and ground-based cameras for distributed teams. This provides a common operating picture for those team members on base and out in the field. Let's look at a use case. There's a report of an intruder climbing a base fence, and security is sent out to investigate. Once on scene, they power on the drones, and at the command center, the operator presses the takeoff button to launch them into the air. The command center team views the scene annotated with AR markers showing suspect, ground unit, and other asset locations. That persistent global AR enables coordination with ground units who have a view from their own location perspective. The distributed team collaboration architecture provides different permissions, including remote piloting, controlling cameras, and monitoring video and data streams by any team member. In the Ops Center, our platform provides overall management of cameras and drones. The view is also available in 3D terrain perspective to bring out vertical separation distances. VRotors is available across PC, Mac, mobile phone, AR and VR headsets, and even web browsers. The platform consists of the user applications that we just mentioned, applications for the connected devices, and an intelligent edge service to which everything is connected. Some key technology innovations include the world-scale AR, the complex management of matching users and devices, real-time data distribution and processing, including machine vision and smart vehicle navigation, and an API providing open integration to other devices. Our platform is live and operational with integrations to drones and cameras. This is the PC application screenshot of remote drone piloting with AR markers in the scene. From the ground at the same location, this is the 360 camera view from which ground controllers can control the camera in any direction. The same AR scene markers are visible along with an AR label from that live drone. This is the mixed reality mobile camera view for the ground units on scene. They can also switch into a virtual cockpit mode to pilot drones. We have a number of live commercial applications. Over the past year, we've hosted hundreds of live drone races with Twitch video gamers and their audiences. Our best pilot is in London, remotely racing a 4G connected drone in Southern California. It's really driven to us to perfect our platform for low latency responsiveness and robustness. Here's a pair of remote pilots in a virtual 3D cockpit, VR racing a real drone on our AR-defined course. We also have enterprise projects with some amazing partners. First, we're working with Dish Network to help them with remote tower inspection using real-time remote drone pilots. We're also working with Maxar on 3D map applications to provide synthetic visualization during bad visibility and low bandwidth conditions. We're working with Honeywell on remote supervision of autonomous air taxi fleets using our multi-vehicle flight management technology. We're also working with IAI to automate the landing process for their next moon mission using our machine vision and auto vehicle navigation capabilities. We are team members with Duke University and the University of Illinois in the ANA Avatar X Prize Robotics Competition. As a team, we have innovated deep space trajectories at NASA JPL, small launch vehicles at Orbital, and pioneered mixed reality at Niantic, creator of Pokemon Go. We have 5 full-time team members supporting product and business development. Our strategy is guided by an elite mentor group from the Air Force, Navy, Virgin Orbit, and NASA JPL. Our innovation has been recognized with selections in the Techstars and Aero Innovate incubators, AFWorks challenges, and attention in the press. If we're selected in this competition, we can deploy our functionality for an immediate technology demonstration utilizing our existing company camera and drone assets, followed by a phase 2 involving a carefully planned integration to base assets. At VRotors, we're enabling the live connection between Marines and seamen to 5G remotely connected drones and ground cameras for a real-time view of base operations. Thank you, and I'd love to take any questions.
Okay, thank you very much, Neil. We're going to pass it off to our team of advisors.
Yeah, Neil, your platform, could it be used by startups that are focused specifically, for example, on cell tower inspection, or would they be competitors?
Absolutely could be used by startups in cell tower inspections or any of the applications that I described. So our long-term goal is to be an underlying platform supporting hardware innovators, service innovators to run their services on our platform. And just to add, it is quite an effort to maintain these applications across the broad breadth of platforms, AR, VR, mobile, and PC. That's really our job to allow these innovators to deploy their services.
And the key technologies you provide, there's, I'm guessing it's mostly around connection management, and then maybe video processing. Is that? Could you sort of summarize what are the key pieces that you provide?
Absolutely, and if I give an analogy, which somewhat of an analogy was like if you want to make a rocket and it launches into space and it works, it's very, there's a lot of complex sort of subtleties to make a system like this work, where you have somebody in London racing a drone real time in Southern California. But it includes certainly a robustness in being able to manage user sessions with the vehicle. If they disconnect, the ability to reconnect with that real-time video and still be aligned with the telemetry and still have control of the vehicle. The world scale AR, so visualization, user experience is absolutely key to any of these kinds of remote vehicle controls. And so we've iterated there, and we're coming out of the video game industry where we have some strengths in providing that. And then underlying the ability to, video stream data and telemetry data, they don't come in at the same rate. Plus we have avatar, voice data, UDP, TCP, and getting all of these things aligned underneath is actually quite a trick, so that from a user point of view, everything is aligned and works. And then finally, the ability I described to you for IAI, what we're doing for automated moon landing, machine vision and all, the ability to add in that real-time autonomy in that cloud connection, if you will. And so we would really look forward to test that kind of improved latency at the Miramar site. But that's where a lot of our additional features are being added.
Great, thank you.
Thank you, sir.
Question about the remote piloting. So absent kind of a beyond visual line of sight waiver from a commercial perspective, how are you achieving, you have visual aids or people on site, or how does that work?
Yeah, yes, sir. In today's regulatory environment, it does involve visual observers. That's correct, to be within the existing framework without a waiver. And so there are really two cases. So one case is you have the uncertified pilot over in London, and we have a certified pilot in the field. And the second case is where you may have a technician at a cell tower who's not certified, but the certified pilot is at the headquarters actually piloting the vehicle. So as long as there's a certified individual at either end, then we're fine, and that's how we work it today. And I'd just like to add, though, we are looking forward to beyond visual line of sight kinds of operations, and what I alluded to with the Maxar work we do with the digital twin, the ability to navigate with, for example, over low bandwidth satellite connections is sort of our foray into that kind of technology to enable that.
Gotcha. Thank you. And then as far as hardware,
Uh-huh.
do you have specific kinds of equipment that you work with, or are you completely agnostic?
Yeah, that's a great question. So we have hyper-focused on the software solution, ranging from, your VR headset and your PC and your Mac down to software that connects to the actual devices. And but we are not a hardware innovator, so we really are a platform to integrate with any hardware innovator who's looking to partner with us, and we're open in that way.
Okay, great. Thank you.
Hey, Neil, thanks for the brief. Colonel Pugh here. I was just going to ask about the disconnected and specifically in a contested electromagnetic spectrum environment, where it's not just network congestion that's causing unpredictability in your connectivity, but it's being intentionally done. You started to get after it, I think, with the comment about the satellite communications. What are your thoughts on being disconnected from the network and then reconnecting to the network? What happens in between with your system?
Yes, sir. That's a great question, and we face this in two of our scenarios today. So one is by a cell tower, there's a lot of interference. The second is in some of the ideating we're doing with Honeywell on the beyond visual line of sight as we go beyond LTE coverage. And so there is certainly a hybrid approach between the autonomy on the device that is required. And so what is the behavior of the vehicle if there's a broken communication link? So in a case of a quadcopter, often you can just either auto navigate to a safe point where you think that there'll be coverage, or where you think you can land safely, or you proceed to the next safe point. If it's a winged vehicle, the risks are a little bit higher, and that needs to be thought through as far as what does the vehicle do. But this is certainly one of the fascinating challenges of this whole problem. How much intelligence do we put on the vehicle versus the edge versus the cloud? And we're excited to be working through that in practical use cases.
Thanks very much for your answer, Neil.
Thank you, sir.
Okay, if we don't have any more, we're about at time. So thank you very much, Neil and VRotors.
Yeah. Thank you, everybody. Thanks for the opportunity.
Okay, next up we have Omnispace.
Good afternoon. Omnispace is creating a hybrid pole-to-pole 5G communication system that will enable seamless transitions between urban, rural, and maritime domains, overcoming the need for multiple devices on multiple networks. We do this by fusing the reach of satellite with the power of cellular to harness our unique 2 gigahertz spectrum, bringing interoperable one network connectivity to users and IoT devices anywhere on the globe. We're partnered on the NSIN Starts project with LinkWest, an industry leader in innovative space platforms and communications. Omnispace was founded by the same investors and technologists who created SiriusXM radio. What a lot of people don't realize about SiriusXM is that in a city, you're listening to the signal off the cellular network, and then when you leave the city, you switch seamlessly over to satellite. Omnispace is harnessing that same technology for global voice and data. We create partnerships with mobile network operators, whereby they have access to our S-band spectrum to improve the quality of service to their existing users. In return, we're able to create seamless connectivity for mobile and IoT devices as they leave the cities and venture to rural and maritime domains, all in the same spectrum. We effectively become the non-cellular roaming partner for anyone or anything leaving the cities in a 5G world. Omnispace owns and operates an extensive legacy capital investment infrastructure in space and on the ground. Here you see the actual footprint of our F2 satellite operating in MEO orbit at 10,600 kilometers. We also leverage a worldwide ground station network that runs the TT&C for F2 in the C-band. F2 also plays a key role in a number of commercial and military pilots around the world. We're currently preparing to pilot a commercial drone solution together with mobile network operator TELUS in Canada to maintain connectivity to UAVs, surveying gas pipelines and other natural resource endeavors when they venture in and out of cellular coverage. In Brazil, Fogais, a natural gas company, is using our terminal to track its barges along 1,600 kilometers of the Amazon River as they go between cities and rural jungle. And finally, as many of you know, our Marines in the high north have been high comms challenged and are seeking new solutions. Over the course of 3 trips north of the Arctic Circle at 70 degrees north latitude, we've used our legacy satellite and a simple prototype terminal to connect the Marines to live WhatsApp video, and later on the move, in a snowstorm, using an omnidirectional antenna, we successfully had the mobile command post you see here connected to NIPRNet. Our globally harmonized 60 megahertz of 2 gigahertz S-band spectrum creates spectrum diversity and increased capacity. We have 6 times the capacity of the only incumbent pole-to-pole mobile satellite services provider, allowing us to unlock and unleash the potential of 5G, not only in cities and on base, but when people and devices venture beyond. We're excited to be working with the top US OEM satellite manufacturer on our next generation NGSO constellation, which we expect to launch in phases to de-risk technology and perfect both waveforms and UEs. At risk of biting off more than we can chew, we actually believe Omnispace has the ability to address all 4 of the problem sets. When we read number 1, we thought this is precisely what Omnispace is built to do. For problem set 2, we believe that the unique characteristics of our S-band system particularly enables very small mobile devices with omnidirectional antennas. Regarding the desire for ad hoc agile networks, Omnispace's 60 megahertz of globally harmonized spectrum provides the opportunity for the Navy and Marines to access and harness our capacity on instant terrestrial networks backed up by the coverage of our satellite. Finally, in line with Omnispace's current Space Pitch Day SBIR contract, we believe that we are already on the path to providing global, resilient enterprise voice and data within the fighting SATCOM vision, which we believe fits within problem set 4. Hopefully, the various demos I described ignited your imagination for the myriad applications of our system. The possibilities for our solution are endless and will be leveraged by commercial enterprise users across industrial IoT verticals. Because we're effectively an MSS, IoT, and personal communication service company, we're eager to tap each of these markets concurrently. We believe, like everyone participating in this event, that these markets will experience explosive growth in the coming decade, and we're positioning ourselves to fill connectivity gaps that other 5G stakeholders are overlooking. We're privileged to have part of our team 3 senior former government leaders. Omnispace executive team has a breadth and depth of experience that we're confident will continue to succeed in creating value. We have leaders from all industries and government, but particularly from the telecoms and aerospace fields. Our and LinkWest engineers and executives have a track record of bringing successful innovations to these areas. Omnispace and LinkWest are truly honored by the opportunity to present here today, and we are thrilled to partner with the Navy, Marines, and Verizon. Thank you, and we look forward to answering your questions.
Okay, thank you very much. Thank you very much, Campbell. And so now we'll turn it over to our esteemed panel of advisors.
Hey, Mike, can I go first? We keep making you go first. Sorry. Hey, Campbell, thanks very much for the brief and cool technology. The question that I have regards quality of service. So certainly, streaming music or getting on NIPRNet and having to wait longer for, your download when you're on the SATCOM than when you are on the 5G network is acceptable in some cases, but not acceptable when it's C2 fires, ISR, or targeting data. So do you have an intelligent way of handling the shift back and forth between the different bandwidth and throughput that you would get or latency issues that you would have shifting back and forth?
That's a great question, sir. Let me try to answer it in 2 little pieces. So the first one is, we actually believe that the latency and lag on our next generation system that we're working on is going to be pretty significantly attractive, the types of speeds you would get from either LEO or a MEO constellation. Call it sub 500 milliseconds. But nevertheless, and so we're trying to keep those times as short as possible. But nevertheless, to answer your question more directly, we're in the midst of building out kind of the core infrastructure in terms of how our satellite core links into whether it's a commercial mobile network operator core or a private government core. And figuring out how those trade-offs work are going to be part of the very important work that we look forward to doing in terms of making sure that those handoffs happen seamlessly. And that's some of the piloting that we're already working on today.
Thanks, Campbell.
Yeah. Campbell, I just want to ask, will your commercial beachhead be? What do you see as your first, application or market segment that you'll pursue heavily?
Another great question. We are currently licensed in some way, shape, or form to cover over 600 million people around the world in various markets. And we are really focused on various IoT applications specifically right now. We know that our spectrum lends itself to certain things. We're not trying to pursue the super high bandwidth, high speed connectivity, but rather focused on smaller bandwidth, absolutely critical communications in any environment, by the way, with small devices and omnidirectional antennas. So I think right off the bat, we're very much focused on the growing small off the grid or items that are both off the grid and on the grid, but have that seamless connectivity. So focusing on providing commercial off the shelf types of connectivity. And by the way, this is all we're very focused on the 3GPP, especially the 5G kind of working group, to make sure that our frequencies and our technology are already built into the pipeline of chipsets that are coming down the pike. And so, I could name a couple different specific application use cases, and we have a sense that it's going to be IoT focused. We are looking at things like secret sauce, but looking at call it global handset provider types about giving critical connectivity. But we're really truly focused on making sure that the chipset is sort of ubiquitously available and that commercial users can buy any device, whether it's a tracking device for Maersk shipping containers to a personal communications device.
Okay, thank you.
Just to touch on that a little further, I get the shipping container, so I'm trying to figure out the cost. Do you see it being more high value IoT devices like a Maersk shipping container or something larger, or is it more the trillions of devices, the sensors that just need to kind of ping the network periodically, but they could be in a remote, or is it both? I don't know what the cost of transmission is.
Yeah, that's a great question. And that, I think, to be frank, is part of the business case analysis that we're probably currently engaged in. But I think, we believe that we have sufficient spectrum relative to some of the other players that are out there now doing similar type things that will have the ability to parse that market. And I think in some cases it would be, the billions or hundreds of billions of devices, down the road using very small drip to larger kind of mid bandwidth use cases. But as I said, as I said in the pitch, we're focused on, we know what we're not good at. There are lots of players out there that are trying to put up, thousands of satellites and feed you really fat pipes, but that requires a significant swap on the ground and in space. And we're focused on the smaller devices. So from the ones of kilobits to the single digit megabit speeds, whatever application use cases we can fit in there, that's what we're focused on.
Perfect. Thank you.
Okay. Well, thank you very much, and we appreciate your time.
Thank you for the opportunity. We appreciate it.
Next up, we have GenXComm.
All right. Hello, everybody. My name is Sriram Vishwanath. I know that's a mouthful. Sriram, you can call me Sriram, and I'm with GenXComm. Not all of us are Gen Xers. We are Generation Next Communications, shortened to GenXComm. And what we do in a nutshell is we enable 5G relays and mesh networks in a way not thought possible before. So we're excited to be here. It's a privilege to be presenting to this august audience. And I'll talk about what we do, how we solve it, and why we make a big difference in enabling 5G all around the US, all around the globe. Essentially what we do is we enable interference cancellation, and through that, we enable 5G relays. From a coverage, capacity, range extension perspective, relays make a huge difference in how you cover everything from spots where there's no coverage to extend coverage in the case of poor penetration, and in the case of millimeter wave and sub-6 radios. We go well beyond just doing relays. We do mesh networks. So we are able to add a lot of intelligence into these relays to be able to enable much greater coverage capacity overall, much better densification and scalability in our networks. All right. So what do? We enable relays through interference cancellation. And what is interference cancellation? When a transmit and receive coexist, they interfere with each other. It's like when I'm talking and you talk at the same time, we interfere. We make that interference go away. Essentially, we enable a transmit and receive that are co-located to coexist with no interference. And the way we do it is super unique, super unique. We do it using RF photonics. This is a really cool way by which you use photonics to cancel the interference in RF. So your radio is operating in the usual bands you operate in: CBRS, proprietary bands, unlicensed, lightly licensed bands, millimeter wave, you pick. We take the signal, convert it to photonics, cancel out the interference, and convert it back. And it's all RF in, RF out, but you use photonics to cancel the interference. This enables a very wideband, very frequency flexible radio, one that can operate in your band of choice and can enable solutions to transmit and receive bidirectionally at the same time, not just in one radio, point to point, but in a mesh fashion, where radios are talking to one another back to back, multi-hop, and are able to connect different parts from the tower all the way to handsets, different devices through a multi-hop mesh network. This gives us very wideband RF capabilities. So we're talking gigahertz bands here. We're talking highly flexible radios, high rejection, interference rejection radios, ultimately in very small form factors using our silicon-based waveguide technology. Ultimately, we're working not just in the telco space, we're working also in the private enterprise space, particularly what we call private 4G, 5G, both in CBRS and other private LTE 5G bands. And with our technology, we're able to improve penetration through walls, in factories, in challenging environments, in rural environments, wherever there is either a need for densification and improved coverage and capacity, or there is none at all, and we can enable it using our interference cancellation mesh architectures. One of the big advantages of this is that you don't need extensive fiber deployments. So you can take a space where there's little infrastructure and bring in the capability to do, provide coverage and capacity, all at ultra reliable, low latency, what's called URLLC communication. So who are we? We are backed by Intel Capital, Asia Capital, BMW, iVentures, a whole slew of other investors, including Bandgap Ventures, FAM Capital, Capital Factory. We're about a little over 40, about 45 to 50 employees now, and growing in Austin and Phoenix. We founded it about 4 years ago. And we have a deep technical talent. We have about 25% PhD holders at the company with strong backgrounds, not just in telco, but in enabling applications for both consumer and enterprise end users. We have multiple federal and commercial engagements, and we're looking at a massive market. We're talking about the SOM alone being tens of billions, the overall TAM being much, much, much greater than that.
Okay, we are at time.
All right. Well, I'm happy to share more about GenXComm further as well. Thank you for your time.
Absolutely. Thank you very much. We'll pass it over to our esteemed advisors.
You touched a little bit on kind of your go-to-market, but just given your investor base and some of the use cases that I just envisioned that they would use, do you see going through the enterprise side first or more on the telecom hardware provider infrastructure play?
What we found is it's a very interesting push-pull between the two. There is a natural, the enterprise is an underserved market, not just generally directly to enterprise, but even through the telcos, and the telcos very much recognize that as a huge opportunity for themselves and for the whole connectivity landscape. And so we see this as a unique push-pull opportunity where we're able to partner with telcos to make a big difference for enterprise customers. And so there is a not just a natural alignment and partnership, but there's a sales model that enables us to work with the telcos to improve their top line, bottom line, while addressing the needs of the enterprise.
Colonel Pugh here. Can you talk a little bit about the privacy and security, desirable features of 5G network for the military as well as for commercial applications? The privacy and security, preserving that from the extension point to the handset or the edge device, and then all the way back to the network.
Yep. In fact, I had a slide on that, but I can speak much more to that. So one of the biggest aspects of what we do is secure private mesh LTE 5G networks. The here are one of the biggest benefits, not just from the end-to-end encryption pieces, but also the authentication, the overall device management features, and the ability to be able to track individual accesses to a much more fine-grained level. So you can do a much greater, much more fine-grained detection of exactly who is doing what within the network. This reduces the attack surface by something like 1000x. It's pretty crazy compared to conventional networks. But the advantage of security and the privacy that comes with it in terms of what we call CUPs, or control and user plane separation architectures in private networks, gives you a great degree of control over who accesses which piece of data and how that access pattern is controlled. So you can do very fine-grained access control together with much greater overall security using our architectures.
Thank you.
A pleasure. Thank you for these questions. These are great questions.
Shriram, just for the interference cancellation, can you talk about the cost of your solution on each side of the RF link? And then is just for the interference cancellation, is this just a hardware solution, or do you need software running on a host processor as well?
It is a hardware solution with firmware to be able to control and manage it. And I'm going in the reverse order to answer your question. Yes, you would have embedded software that goes with it. The embedded software is actually the easiest piece because it would go into the existing application processor. The hardware piece itself is a combination of silicon with additional RF components and scales extremely well as it is silicon. So if it were a complicated non-silicon structure, its scaling behavior would be much harder. But here, as the volume increases, the costs steadily go down. So one of the aspects of us working on this with you would be to be able to scale this to a point where the resulting costs of the silicon become trivial compared to the rest of the infrastructure. The beauty of it is because it's a silicon-based canceller and it's in the shunt path, that means it doesn't go on the transmit or receive, it goes between. It doesn't mess with your transmit, doesn't mess with your receive. It's waveform agnostic. It is protocol agnostic. And all it does is sit in the middle and give you this cancellation behavior that's tunable and wideband.
Great, thank you very much.
My pleasure.
Yeah, Colonel Pugh again. I think you just answered my question, but no additional modifications or cost for the edge devices.
None at all. In fact, you could do just on one side if you wanted to. The cancellation doesn't have to happen everywhere to get the benefit. The beauty of inference cancellation, even if you did it on one device once, you start seeing the benefits right away.
Thanks.
any interference I can get rid of, I'm very happy to work with you to make sure it disappears.
Yeah, assuming that means intentional interference as well as unintentional interference, co-site interference type stuff.
Yes. So co-site, any co-located interference. It could be two different waveforms. You could be talking about radar and something else. You could be talking about two different protocols.
Adversary jamming.
Adversarial jamming, intentional, unintentional jamming, deliberate jamming to protect your own communications. All of these configurations are not just good use cases, but many use cases of RF photonics is the best way to solve them.
Okay, any last questions? Okay, all right. Well, thank you very much for your time, and we appreciate you.
Thank you for taking the time.
Next up, COMSovereign.
Okay, I want to thank you all for the opportunity to present our technology today in 5G competition. Let me start by briefly describing COMSovereign, since we're approaching 5G in a fairly unique way. COMSovereign is a holding company that has acquired several leading microcap technology companies focused on connecting 5G. Our portfolio now includes wireless and optical communications, power, and portable infrastructure. We've developed differentiated technology by leveraging disparate strengths that are not commonly mutually grown. Briefly, our team has more than a decade of experience as a non-traditional contractor for various government agencies. Topics have included software-defined radio systems, as well as developing cellular IoT use cases for DoD applications. Several of our technologies cut across multiple NSIN problem statements. Today, I'll discuss 5G relays and support for episodic networks. Our instant on 5G radio solutions can be combined with portable aerial platforms today. And additionally, in-band full duplex for 5G relay really improves capacity and reduces latency. The following slides will amplify these three highlighted technologies. VNC is a leader in rapid deployable 4 and 5G radio solutions, and these include the radio, base station, and integrated network core function, and thereby supports an independent and autonomous network bubble. The solution is hosted in 2 form factors. One is a ruggedized battery-powered solution called RAID, and supports both dismounted and mounted operations. A second solution is optimized for swap and weighs only a couple pounds, called Featherlight. The Featherlight has been integrated into several UAS solutions, including our own drone products described next. The NFV capability hosts third-party applications, and shown here is an Android application called LifeRing, providing common operating picture software. This is fully embedded within the RAID and requires no external server. And this extends the eyes and ears of the battlefield with functions such as video, a call for fire capability, push to talk, really to anyone and anywhere in the world. Drone aviation complements the VNC solutions with aerial platforms. Tethered aerostats and drones improve wireless transmission range while providing long on-station times. The WASP systems host VNC Featherlight radios to provide instant network solutions in addition to ISR functions. The high ceiling of WASP aerostats improve coverage over temporary tower installations and can operate for weeks. The Watt 200 quad rotor can be deployed in a matter of minutes, and it can operate either from a battery or a generator solutions. Drones Watt and VNC's Featherlight are now fully integrated as a single package solution for airborne 4 and 5G coverage. VNC and drone are complemented with Lexstrom's full duplex capability. Full duplex remains one of those last holdouts and promises to improve both transmission capacity and reduce latency. To get greater than 100 dB of self-interference cancellation, we really require multiple tools and methods operating in concert, and Lexstrom incorporates 3 self-interference domains, including baseband, RF, and at the antenna. Lectrum's most notable differentiation is the use of its spatial domain processing for post-antenna signal cancellation. The passive self-interference cancellation method is fundamentally different by trying to eliminate the multipath interference before it's seen. With optimized antenna patterns, we have seen an additional 65 dB or better of attenuation in this domain. Coupled with the baseband and RF techniques, it's now possible to achieve the necessary link margins for terrestrial systems. There we go. We request the opportunity to provide a demonstration integrating several of our technologies in a mobile 5G relay compatible with expeditionary force operation. VNC's network bubble coupled to infantry or recon units can demonstrate the use of the COP software for battlefield simulations. To this, we can add an additional aerial asset, such as our tethered UAS, for additional demonstration support and promote greater operational flexibility. We would also like to demonstrate a full duplex system. We would install a link of full duplex test units to the living lab, which can be equipped with surrogate COP UEs. And these would measure and demonstrate both qualitative and quantitative improvements through our operational use cases. We're currently operating only in FR1, but could migrate to an FR2 solution to be compatible with the living lab given sufficient time. While our solutions are capable of operating independently, we also support backhauling to the living lab. These have previously been demonstrated through both satellite and tactical mesh backhauls, and one concept to explore is a patrol group operating COP handsets in an isolated network. This network can rejoin the living lab upon entering or returning to the base or depot environments, and the patrol would be using the exact same UE and handsets in both environments.
All right, Justin.
Yep.
Thank you very much. We have reached time.
That's
Appreciate
good.
you.
I just finished. Thank you.
Work together. Teamwork makes the dream work. We're going to pass it off to our esteemed advisors for some question and answer.
Perfect. Thank you.
Thanks for that. That was good. As you contemplate moving from the DoD towards commercial, where do you see the primary use case here? Because it seems like there's a lot going on, and the orchestration is the key, but how you can kind of pull that into the commercial sphere right away? Yeah,
that's a good question. I mean, most of it to date has been primarily first responders, so I won't call it commercial. It's still in the public space, but primarily our traction has been within CBP for the aerostats along the border. Also, a lot of use cases for the backpack and feather lights in typical first responder or emergency response situations, post-disaster, those sort of things. Essentially, where your infrastructure is either knocked out, for example, Puerto Rico, where building towers in a rapid way is not really all that feasible. So you can essentially bring these in, put them up in the sky, and you've got at least a temporary infrastructure in place in minutes.
Okay, perfect. Thank you.
I think I may have two questions, but they're related. So one is the endpoint device RAID, I think it was called, as well as the either aerostat or drone-based tower in the sky kind of thing. Those are all proprietary solutions, or are those you can just use any 5G handset, for example, to connect to that to the aerostat?
That's a very good question. It's an open system, so it complies with 3GPP. So you can go buy a Samsung phone or an Apple phone or whatever. You can use a tactical, ruggedized phone. We've got all of them in our library, if you will, and so our demonstrations typically use all of them and the above. So you can essentially roam with a handset from Best Buy across our network or back into an AT&T or Verizon network.
Oh no, it will be like $150,000 handset that's ruggedized to survive in minus 50 degrees Celsius. But we just don't want to buy 180,000 more of them after we bought the first ones. But I appreciate your confidence in our acquisition system. And then the second question was, I think you had mentioned simulation as part of the capabilities that you would bring. Do you have a modeling in sim or virtualized version of this system that you can experiment with?
I wouldn't say it's a simulated system. It's actually we'll call it a test bench system. It's something we've got both a test range, our own test range, and then we also have a test lab where we run a lot of the experiments.
Yeah, so physical, not a virtualized version.
Correct, yeah.
Got it. Okay, great. And then, sorry, 3 questions and then I'll stop. The other one was, does this extend the network Similar to the last brief, I don't know if you were dialed in for the last one, but does it extend the network, or is it a standalone private network?
No, that's a very good question. It actually, you can operate either way. So the key to it is that the VNC solution can integrate all of the G-Node B and core together, essentially, so you can wander off and be your own network. But equivalently, you can also equip it to backhaul into an existing core network. So we can cut it in a different way, slice it such that we've got our G-Node B talking back, for example, to the Miramar core. And that way, they're essentially collaborative or extended by the virtue of the fact that our base station is connected into the other core. Equivalently, you can also just roam from one network to the other in a traditional way you would with any handset.
Great, thank you.
Dustin, for the virtual NetComm product, do you see that, or do you have any plans to take that into enterprise? Any initial traction there, and also any plans to support CBRS frequencies?
That's a very good question as well. We actually are currently supporting CBRS frequencies. That's really our go-to for first market entry as 5G is still maturing. Our primary market for a solution like this is actually a enterprise LTE solution in CBRS. So that's, I would say, where the meat of our effort is going right now, with 5G kind of a development effort to be baked in as the frequencies become accessible for those of us who don't have, accessible licenses.
Got it. Thanks. That's very helpful.
Okay, any other questions going once? All right, well, thank you very much, Dustin. We appreciate your time, and thank you to COMSovereign.
You're very welcome. Thank you for having us. Really appreciate the ability to pitch for you. So thank you again.